Sir, you're not audible.
Now can you hear me?
Yes, sir.
Am I audible to everyone?
Yes, sir.
Yes, sir.
Student, can I get a response? Can you hear me?
Yes, sir.
Nishi, yes, sir. Great. Thank you. Fine. So once again, welcome back. I hope that you remember what we have discussed in the last class. So if anyone have any problem or any point that you want to discuss pertaining to last class, please let me know. So I'll give you 2 3 minutes on the discussion of the past class. Then we'll go ahead. Anyone have any confusion, please let me know. Meanwhile, I have shared a document, if you remember. I shared a document on your WhatsApp group and I requested everyone to please go through that document. Have you read that document? Anyone? Do you find any difficulty or any new thing what we have not discussed in the last class? Can I get a response because I'm not able to hear from anyone. My voice is not loud. Why this is happening? I don't know. Can you hear me now? Is it loud and clear?
So not that much, sir.
Okay. So I keep my speaker like this. So fine. Okay. Banu, you are still ready. Fine. Not a problem. So see, the major part of that document, why did I share that document with you? To tell you about this diagram. This is a network diagram. Mainly you have to read this diagram in detail. Because if you see this network, you find that these three network represent three different connections, three different algorithms, three different architectures of a network designing. The first one, which is a centralized one, we are still using it in a document sharing, in your email services. Everything is which is working now, even in digital platform, what is LMS is working, everything is working in a centralized mode. So till now, what we are working is a centralized network diagram where every node, every network is connected with a center node or with a server. So if anything crash or any failure happen into the central node or the coordinator node, we are not able to work. Let's assume the server of Beacon crashes. So either I'm working on a Beacon LMS, it will not work. Either I'm working on a Beacon examination, that will not work. Even our Zoom ID will stop working. The reason being, Beacon is working on a centralized network distribution. So the major problem with the centralized network are the success of entire network depend on central coordinator. Fine. So this was a diagram which explains the centralized network system. Then come on, the remaining two. The second one is talking about decentralized, and third one is talking about the distributed. So if you see into this decentralized diagram, although we have a coordinator in center, like this is a coordinator, this is a coordinator, this is a coordinator, this is a coordinator, this node is a coordinator, where multiple network or multiple parties or multiple node is connected over here. So if you would like to pass on information, you have a requirement of this coordinator. So now let a situation, if something went wrong with this coordinator, the coordinator A, which is given in a center, still I'm in position to work in this decentralized network since other coordinator are working. If a failure of a server in Visakhapatnam, the Hyderabad server of VTEM is working. So if I have created a decentralized network, so failure of one server or failure of main coordinator is not going to impact my business, is not going to impact of my sharing, it's not going to impact any type of transaction which is happening to my network. Similarly, these decentralized nodes or these decentralized concepts used in a blockchain. After that, the decentralized become more advanced and it becomes distributed one, where I does not require any coordinator, I does not require any central node which help us in sharing of information. Rather than requirement of a central coordinator, every node will act as a coordinator by itself. So if I join in a network, I become a coordinator. I can easily pass on the information. The reason being, this use of concept of consensus, this use of concept of public ledger. So till now, what most of the organization is working, or most internet provider, internet application, internet services is working in a centralized mode, which is moving slowly towards decentralized and distributed. Like Bitcoin is a distributed one, but most of the blockchain services are decentralized because they have their own limitation. They want to work for a particular organization. So just if you recall or if you remember these three diagrams, you are able to answer all the questions pertaining to a centralized, decentralized, even a blockchain architecture. So that was my purpose behind sharing this document. Rest we have already made a discussion in the last class. So fine. So we'll return back on our regular discussion, what we were doing and where we have left this. Anyone have a problem to understand these two diagrams? Anyone have a problem to understanding the purpose of why we are moving from
Sir, the one doubt, sir, how can we differentiate the decentralized
yes,
structure from? Hello?
Shrikant, you are not audible.
So can you hear me now, sir?
Still, I'm not getting your voice.
Sir. How about now? Hello?
Shrikant, we can hear you. There's problem with sir.
Can you hear Shrikant?
Sir, Aishwarya told that she can hear me properly, but
Fine. Okay.
otherwise I'll type it in the chat box.
This is a fault from my end. What is happening?
I think so, sir, because my voice can be heard by other people, but not.
What happened with your class? Okay, you people can hear him, but I can't. You can hear me, that's fine. I do not want to disturb anything now. Last class, I explained you the meaning, the algorithm and architecture as well as fundamental of this field. In today's class, we'll start a discussion with how blockchain is related to Bitcoin. So here, we'll try to explain a Bitcoin in detail. Shrikant, your question was how can we differentiate between decentralized and distributed network? Decentralized network, where you can say we require permission to enter into that network. In decentralized, we require permission to enter into that network. But in distributed, there is no requirement of permission. Like Bitcoin is a distributed network. We can enter into Bitcoin just by opening a wallet. It does not require permission who have created this network. I does not require to create any, you can say KYC kind of document. But in case of decentralized, we still require a permission from a coordinator node. The coordinator node has to provide me a permission. Without getting a permission from a coordinator node, I cannot enter into that decentralized kind of a network. The distributed network does not require any permission. So
Okay.
the other limitation of distributed and centralized, when you are using or when you are creating a distributed system, you require a more security norm, because anyone who is entering into your network may be an alien person for you. You may not know that person, so you may create a malicious transaction. It may try to disturb the entire network at a time. That's why when anyone or any person try to create a blockchain rather than distributed, they prefer a decentralized network, because distributed networks require more security norm, require more algorithm, require more, you can say, because any alien can enter, so it create a problem of a security and privacy. Fine. So when we are talking about a Bitcoin in today's class, first I try to explain you a Bitcoin in much detail. Because once you understand the operation of Bitcoin, it becomes easy to apply blockchain elsewhere. Because blockchain is a universally accepted that the concept of blockchain was first used in creation of a Bitcoin. But that was not a true story. Blockchain was used in the past as well. But universally we accept that blockchain technology is the first, Bitcoin is the first implementation of a blockchain. So that's why I'm giving a detail about this Bitcoin, how this Bitcoin is working. When we are talking about a Bitcoin, the Bitcoin concept started somewhere in 2009, where a person called Nakamoto Satoshi has created a blockchain diagram, and he has a own thought that none of the government have a right to control currency. The thought behind Bitcoin creation is government should not have a right to control my wealth. Like each person or a certain set of economists have a thought that government should not have a right to control, government should not have a right to control my wealth. Because if I have my wealth, if I have my currency, if I have a money, it should not be controlled by any central person. It should not be controlled by any government of any country, because that's my hard-earned money. So as per that thought, these economists decided to develop a currency which will be totally decentralized, where involvement of government is not required. So as per that thought, Bitcoin has been evolved, or cryptocurrency has been evolved in the market. Because see, if I'm earning money, still my money belongs to RBI. If let's assume Ethan is giving me a salary of X amount, although I'm earning this salary by my hard work, but if you see that currency is clearly mentioned, every currency have a bearer bond where RBI promised to pay you certain sum. So these gentlemen, these group of economists decided that rather than getting a foundation from a government, they try to create a certain money, certain currency, which does not require any permission from anyone. And that thought, that group of economists developed a concept where money will be digged out, money will be secured, money will be created by use of software algorithm. And once money is created by software algorithm, it clearly says it does not require a permission from any government. So how they will control it? It will be controlled by the bearer of a money. In simple language, if I'm holding a Bitcoin, I have a right to control the flow of a Bitcoin. If you are holding a Bitcoin, you have a right to control a Bitcoin. So this becomes a decentralized currency, number one. And to control it, we require a peer peer-to-peer network. The person who holds have a right to control. Fine. And the third one, since it does not require any interference, it does not require any hindrance, so they created this network which is permissionless. So anyone can join, anyone can buy it, anyone can enter into that network, and if they hold BTC, if they hold Bitcoin, they are free to sell to anyone without getting approval to government or without getting approval to any central body. That was the logic behind it. Now, see the problem over here, because once you decided you require a currency which will be not controlled by a central body, it will be controlled by all the parties which is involved into that transaction, which was not possible with the existing network algorithm, which was not possible by the simple architecture of a network. Like if I'm assigning an internet, let's say I'm writing www.google.co.in or google.com. My writing of www.google.com is an example of a centralized network system. I cannot access Google until unless Google is not allow me to use it. So existing network cannot solve the problem what these economists have identified. If they use an existing network of a centralized thing or centralized architecture, the problem of permissionless is not possible. The right of a peer-to-peer validation will be not transferred to the person who are entering into that network. So they have a requirement of a new technology. So that was a reason why blockchain has been evolved. Blockchain do have a limitation. Don't think that blockchain does not have a limitation. Blockchain do have a many limitation. Like I cannot write a looping program in a blockchain. I cannot create a loop in a blockchain. I cannot repeat the same transaction every time, which is possible in normal network. This is possible in normal programming language. Like if I'm writing in a program in C or C++, I can use loop, but this is not allowed in a blockchain. So although blockchain have overcome multiple issues or multiple shortcomings in a network diagram, but still have a limitation. So as per this concept, they decided that they require a new technology, new network architecture where they can start a new type of currency which can be decentralized, where peer or the person who are buying or selling it will be have a control right. Now, when you decided to create a currency, the value of currency will depend on a supply, or value of currency will depend on a demand. Like if I ask a simple question, what is the current value of USD in comparison to Indian currency? You will say that approx 74 rupees. Why is happening? Reason being, dollar have higher demand in comparison to supply. If I ask the question, what is the currency value of Bangladesh? You will say it's hardly a 0.81. It means for Bangladesh, Indian currency is more valuable. The logic behind it is a question of a demand and supply. Similarly, once you decided that I'll create a new type of cryptographical currency, you have to design a certain architecture where you can control the supply of this currency. Because if anyone can start extracting Bitcoin, if anyone starts creating a Bitcoin, the supply will be very high and the value of currency will go down. So to overcome that situation, they have created a network where they try to control a supply. Then how they can control a supply? The controlling of supply is depend on the reward given to a miner or reward given to a creator of a fund. So what exactly this what Bitcoin algorithm is tell about? The rate of creation will be adjusted for every 2016 block. Now, if a blockchain miner is creating a block Bitcoin, that is simply known as a creation of a block. If I'm mining a Bitcoin, if I'm creating a Bitcoin, it says that I'm creating a block into a network. So after creation of every 2016 block, the price adjustment, the reward adjustment will be there. Like if first time I'm creating a blockchain, I'll get a reward X. Once the total number of blocks becomes 2016, the reward will go down by 50%. Similarly, if total number of blocks again increase by 2016, the reward will be reduced by 50%. So if I'm reducing a cost, if I'm reducing a reward, automatically it says that nobody will try to create more blocks in a market. So if you see a projected diagram of Bitcoin, because I started somewhere in 2009, when they have mined the first block, block number 0, and that is called reward era of 1. In that reward era, the miner was getting a maximum reward out of it. In a 0, when they have started the first, the total block or total BTC per block was just 50. And that was a story in 2009. That era ended for a 4 years. Every time when they are doing a mining, they are getting a certain block and reward is paid. That the certain amount of reward is paid to them. Now, once these number of blocks are increasing, the reward is going reduced. First time they are paying a 50. After that, the per block, the total number of BTC generated 25. Then it generated 12.5. Then it generated, currently it's generating 6.25 only. After 4 years, then they have reached on a 2000 to 21 million kind of stuff. They will reduce to 0. So by writing an algorithm, by using our architecture to control this supply, the supply of Bitcoin will remain in the market. So here the first thing that as a computer science graduate you have to understand, when I'm designing a permissionless network, when I try to create a permissionless distributed network, we should create a security where supply of blocks should be limited. Otherwise, your blockchain becomes too long to control it. Your blockchain, your chain system becomes too long that to validate every transaction, you require a lot of time to complete it. So this Bitcoin algorithm clearly explains every time when you are mining Bitcoin, when you are creating a block, the reward will be reduced. So when reward becomes 0, people will stop mining Bitcoin. So it says that around 2050, the new block or new BTC will stop entering into a blockchain environment, because that time reward becomes 0. The way reward is reducing from 2009 onward. Currently, our reward, if any miner is digging any block, the reward is 12.50. It means if you are mining, writing an algorithm of a Bitcoin, per block you will generate just 12.50 Bitcoin. It will reduce to 0 around 2050. So the number of Bitcoin will remain limited in a market, and due to that limitation, the cost will remain intact. So always remember, when you are designing a permissionless blockchain, you have to write an algorithm where you have to create a limitation of addition of a block. You cannot make it infinite. You should not create a chain where the number of blocks will keep growing till infinite. Otherwise, it will create a problem of authentication. It will create problem of validation. Now, just try to understand a simple technology in a Bitcoin transfer. What I've given an example last time in a banking sector, now change it into a Bitcoin center. If there's a 4%, just try to make a transfer of money using a Bitcoin rather than a normal currency. They will use the same concept, but rather than transfer happening into normal mode, they have to open a transfer in a Bitcoin wallet. So a step one in Bitcoin transfer, the person who want to make a transfer, like here, Alice want to make a transfer of 50 to Bob, and then Bob want to make a transfer of 30 to Jen, and so on. So a step one, the Alice has to open their account in a Bitcoin wallet. Anyone who want to be into Bitcoin, who want to buy a Bitcoin, who want to sell a Bitcoin, he has to open a account into a Bitcoin wallet. So Alice will start his transaction. He will open her Bitcoin. He will see how many Bitcoin is holding with Alice. Is showing that the total Bitcoin is 477.06. That's the holding status of our Alice. He will simply write down how many Bitcoins you want to make a transfer and click on a send. That's a simple transaction, very much similar to a banking transaction. You have to write your passport, click on an account where you want to pay, and click on that. But it's not simple like a banking transaction. I have given a instruction, it will execute it. The first part, you are sending the information. That information will pass on to, this is just a simple sender. The sender can be written like that. You have to go into a wallet. After going into a wallet, you have to make a request, and that request will propagate it to every node. Like Alice want to send a $50 or a 1 Bitcoin to Bob. So once Alice will click on a send, that message will propagate it among all the blockchain. Every blockchain node will get this information that Alice want to transfer a 50 rupees or a 1 Bitcoin to a new person. His name is Bob. Once this message is propagated, now it's a responsibility of miner, or it's a responsibility of person who have created this block, created this block to validate this transaction, to find out whether this transaction or whether this transfer of money can be allowed by Alice or not. So he will use a simple hash function, what I explained in the last class. They have to check the hash function where the Alice has the balance or not. They will check all historical information, and on a basis of that historical information, the miner will give a validation, or miner will provide a detail. Miner will provide a detail that this information or this transaction can be validated. If miners find out that this information is validated, it will update it and propagate it back into a network. That will propagate it and back into the network, that Alice can make a transfer of 1 Bitcoin to Bob, or Alice can make a transfer of rupees 50 to Bob. Once this is approved by a miner, now the money will be received to Bob wallet. Now, when money is received to a Bob, it may be a situation that Bob is an existing customer of that block, Bob is an existing node of this blockchain, or it may be possible Bob is a new customer to this entire chain, or a new entrant into that chain. So if Bob is a new entrant, he will add this record in a block. The block will keep a record that initially Alice have a 476 BTC. Out of that 477.06 BTC, 1 BTC, 1 Bitcoin has been transferred to Bob, and entire time stamp will be visible to everyone. Time stamp, I've already explained in the last class, that it's a historical information which will be kept into the entire system. So once the transfer will take place, once it's approved by a miner, the Bob will get the entire information as a receiver. So here, if you see all the information of a security, or all the information that is happening in a single transaction, will be stored in a single block. Now, when I'm using a term all the transactions pertaining to a Bitcoin will be stored in a single block. It means the success of a blockchain network, the security of a blockchain network totally depend on construction of a block. If my blocks are secured enough, nobody can create a malicious transaction into it. Nobody can temper my block. So to understand this security purpose, we have to go in detail about what is the exact structure of a block. Why I'm using term that the success of a blockchain depend on the structure of a block, or the security of a blockchain depend on a structure of a block. Reason behind, all the information of making transaction, all the information of doing any type of sell or buy activity will be recorded in a single block. So for security aspect, we have to understand what is the exact structure of a block. Why block becomes so important for a success of a blockchain. If you see a typical structure of a block, we have just a typical structure of a block, which is indicated by block number 51, 52, and 53. Here, you will find a two features. The first thing I say that a proof of a work, and it says that a previous block. Similarly, this 52 is talking about what is the proof of a work and what is my previous block. Similarly, like 53, 54, and henceforth. So every block to make it simple in a Bitcoin term, if you are a miner and you have mined approx one block which contains around 50 blocks. So your block which is mined by you will create or will be keep a record of all type of transaction which is happening or which is related to that total 50 Bitcoin. So if I'm a miner, I have created a block number 51. There is a second miner who has created block number 52. There is a third miner who has created block number 56. So anything or any transaction which is happening to my Bitcoin, what I have mined, will be kept in a single block. All the information pertaining to that transfer will be kept in a single block, that is block number 51. So it may be possible when I mine 50 Bitcoin, the 40 has been sold to Mr. X, 10 has been sold to Mr. Y. After a certain time period, Mr. X transferred 10 of his Bitcoin to Mr. Z, while Y transferred 5 of their Bitcoin to Mr. A. So all these information pertaining to my 50 Bitcoin will stored in my block. So every block in a blockchain, meaning a Bitcoin, is a representation of the miner who have mined that coin and propagated into a blockchain network. So block number 51 is talking about one miner. Block number 52 is talking about another miner. Block number 53 is talking about another miner. So this block becomes very important because once I see a block in detail, I am able to find out all the information pertaining to my transaction. Who is owning my money? Who have this blockchain? Or where is my 50 block? 50 Bitcoin has been transferred. Who is the ultimate owner of it? Fine. So if my block are secured, if I'm designing the algorithm, I'm designing the architecture where nobody can enter into my block, definitely my entire blockchain will be secure. That's why the security of entire blockchain depend on the structure of a block, which depend on the algorithm and architecture which is designed into these blocks. So we'll go on a detail what should be the structure of a block. And here I'll give an example of a Bitcoin because we have already information on that. So when we are talking about the structure of a Bitcoin can average block in a Bitcoin have an information of a more than 500 transactions. Because from 2009 onwards, if you see a block of any Bitcoin, going to a detail of that block, you can find out that the average block has 500 transaction information in it. When we are talking about the 500 transactions, it means the coin, the BTC, which is generated by a miner, has transferred to 449 places, has been transacted 449 times into that peer-to-peer network. So that's the average transaction recorded by any block, but this is not limited. It may be possible certain block have a 1000 transaction, certain block have just 10 transactions because miners have mined just last year. But the average transaction, if you find in any block, has a near to 500. Okay, so here, a block will contain a header and a list of transactions. This is just a typical block identification which happen into a blockchain. If you see, this is a block, fine, a block of a Bitcoin. The first part is talking about a header. This summary is nothing but a header. While the latter part keep a record of a transaction. This is just copy from a blockchain.info. This diagram is available over there. If you are not finding or you are finding a difficulty to see the given number or given name over here, you can go on that site and try to download that picture which is available. So the block, mainly the block have a two part. Every block have a two part. One is called block header, and other is called list of transactions. If you see into a block header, here this is a block header where I keep a record like what is the height of block, what are the timestamps, who have created, how many transactions has been happened. All the details will be given into this block header. This block number have has 500 312. So this is a specific block which is created by a certain miner, and who is the miner? It will also recorded over here. The number of mine who has mined it, it will recorded over here. The number of Bitcoin which is linked to this block is given over here. It's showing that around 12.5 BTC. So when this block has been mined, the miner get as a reward in a form of 12.5 BTC. So the first part of block will contain detail about the transaction, miner, height, how many transactions took place into it. And the second part of block will tell you about a list of a transaction. List of transaction, here the party name will be not displayed. The party name will be not displayed, but we get a hash code. So yeah. If you see the transaction view of any header of this block, you'll find that the name of party is not displayed. Rather than name, the validation, which is validated by a miner, a hash function will be created, and the hash function will let you know who is the actual party who have purchased or sell this blockchain or sell this Bitcoin in this particular block. See, the first transaction says that no input. It clearly says that the first transaction, when miner is transferring, miner is selling their Bitcoin to certain party. So this red color indicates the first transaction into a blockchain. The first transaction into a given block. The red color always indicates that miner is transferring their Bitcoin to certain party in a given block. While if you find out in other transaction, we have a detail of a seller, we have a detail of a buyer. We have a detail of a seller, we have a detail of a buyer. And what is the transaction amount is also given. So this block, if I get the information of a block, I can find out every movement of my money, every movement of my Bitcoin. So if I'm getting all the information pertaining to my Bitcoin at one place, definitely it will be a secure system, and Nobody can temper my block without a validation from a miner. Now let's assume I want to enter into a block of 500, 312. If I want to buy something from this block, or if I want to enter into that block, what I'll do, I'll give a buy request. If anyone is interested to sell, they will sell their Bitcoin holding to me. Once I create this transaction, once I made a request of this transaction, that will propagated on all the nodes, all the party which is involved into this block. And it's a responsibility of miner to approve my transaction. Approving a transaction, it means solving a hash function, solving a complex mathematical function. So once they solve this complex mathematical function, a new hash code will generated for me, and it will propagated to all the parties pertaining to this block. And I will be added into this transaction code like a buyer, and someone who sell their Bitcoin to me, he will be added as a seller. So by using that hash function, by using that hashtag, anyone can validate whether I'm a valid person to enter into it or not. So if that is the, you can say the cryptography, that is the architecture used in a block, nobody can penetrate blocks in any format. Now, we'll go in detail about a block header, what exactly these header mean, how these header are created, and what are the information shared by this header. If you see a header name that is saying that a block has 500, 312, what do you mean by this block header? So every time when I read a block header, it represents a three thing to me. It represents a three major information to any person or any node into that blockchain. The first part of the block will let you know about a historical information. The second one is known about a mining status, and third one will tell you about a Marshall tree root information. So just by seeing the header, anyone, any party who is a part of that blockchain can decode it and can find out the validation of this transaction, whether this transaction is valid or this transaction is invalid or someone try to temper it. So the first part, it says that every time when I write a header name or when I create a header name, it always keeps a record of a previous block. By this mechanism, my block becomes a temper proof. Why I'm using so? By using this previous block as, my block becomes temper proof. Just see simple example. If I want to edit a detail of my block, I want to edit a detail of H2 block. So if I want to make a modification or if I want to enter any malicious information as H2, automatically I have to update all the blocks, all the related blocks after that. So if I try to temper H2, automatically I have to temper H3, I have to temper H4, I have to temper H5, I have to temper H6, and henceforth. So due to the linkage with the previous block has, it becomes impossible to temper any block in between. Like if I want to change a mark of a class 10, that have an impact on a 12, that have an impact on a graduation, that have an impact on a PG, that have an impact on my PhD marks, and that have an impact on my job. So if I change a marks of a 10, I have to make a changes into each part. Once I change a marks of 10, I have to make a change in a marks of 12. I have to make a change in marks in a graduation. Then I will go and try to change a marks in a PhD and like that. So which is not possible by any person, which is not possible by any party into that particular block, because without getting a validation proof, without solving a hash transaction without getting a validation ID from a miner, I cannot make manipulation into this block header. So due to the relation with the previous hash, with the relation with the previous block hash, always this blockchain become a this blockchain become a tempered proof, and in any case, nobody can temper it, because once you try to temper, it have an impact on the rest of a block, and it will create invalidation. It will create a message which will propagate everywhere that someone try to manipulate or someone try to deviate from a given hash function. So it will automatically null and void, and that particular block will be eliminated from a system. So it creates a sort of security just by adding a current hash with the previous one. Next part, the next part of header will tell you about what are the mining information, mining stats, which will tell you something when it's mining, what was the total coin there, how the complexity stand into it. So here, the major function which is included by a miner is a hash function. And if you see this hash function, there is a three part of it. The first part, the header, the current header should have a linkage of a past header. It means the hash of k will be a function of hash of k minus 1, that's the previous header, plus the time stamp when it's getting changed, and the nonce. Nonce is nothing, it's a random value which is created for a complexity into operation. Nonce is just a random value which is created to add complexity. Generally, when you see a nonce in a Bitcoin concept, you find that around 18 to 20 zero has been prefixed before any number. Like 20 times 0, then it becomes 5320. 20 times 0 or 18 times 0, then it becomes 11125, like that. So mainly the purpose of use of this nonce in a Bitcoin mining or Bitcoin hash function is to create a security, to add an extra security which help us to make entire transaction tamper proof. So when we are writing a hash function, always remember the hash of current header will link to the previous header, then it will give a timestamp, then you have to use a random number, but that random number should be a complex one, so nobody can solve easily. Nobody can have a right to solve it easily at any concept or any given a time. So what I'll do, it may be possible I add 100 0 if required, I add 20 0, I'll add 50 0 as a prefix or a suffix, which will make it a more complex to solve, which will make it more complex to get it easily resolved. So that's the second part of this header. The third part of a header is a Merkle tree. I've already explained this Merkle tree yesterday, but once again, every header will get a detail from a leaf header. Like if I'm talking about a header number 1, which is considered as a root header, automatically it have a linkage with intermediate header L1 or H0 and H1. Similarly, this H0 have a linkage with H00 and H01. So every transaction which is happening at a leaf header will have an impact on a root header, which have a direct impact on it. So by following this Merkle tree, it will also add extra security into a block. So the purpose of entire blockchain to make it secure is it only possible by a structure of a block header. Only block header architecture make this blockchain a tempered proof. So when you are designing your blockchain, when you try to design your blockchain either in Hyperledger or Ethereum, you will understand that how important is designing of a header, because the entire security purpose, entire validation, all the success or all you can say making your entire blockchain tamper proof is depend on architecture of a header only. Fine. Have you understand this concept of a header? Although I'm not getting voice, if anyone write in a chat box, will help me out.
So once can you revise the previous one, previous slide once? Hello,
We can't, I
sir.
think there is a problem
Previous
on
slide.
our lap.
Sorry, revise this.
I want to discover until unless I'm getting my voice clear. So do you understand the fine? Do you understand this concept of a header? When you're designing your block, always remember header is the most important. Where then when we are writing our architecture. Okay, fine. Previous slide you are talking about this one or this one?
This one, sir.
Slide number 35 or 36?
35, sir.
35, fine. This one. Okay. See, just a little bit summary for you, everyone. When we are designing a blockchain, the purpose of designing a blockchain it should be a tamper proof. There are no malicious transactions took place in my entire blockchain. I want to create a security for entire transaction, so it will be validated by a challenge response system, or it will be validated by solving a mathematical hash function, or it will be validated using a different mathematical algorithm. So if I try to create a more secure environment, I have to write or I have to create an architecture that becomes very complex to solve. So to make it, when I'm designing a block, my major focus on designing of a header of my block, because header is something which creates every information pertaining to my block, like all the information related to every transaction will kept in this entire block, and this block have a two parts. The first is talking about header, and second is talking about the transaction. When I'm designing the header of my block will tell me about a three major information. The first information is talking about what was the transaction in my previous header, what was the transaction in my previous block. Second is talking about what the miner information, how much Bitcoin the miner has received, how many transactions the miner is doing. So it's a responsibility of miner to create a complex header name. It's a responsibility of a mining person or a person who have a right to validate to create a complex mathematical function. So I'm just giving an example how to create a complex mathematical hash function which make your block tamper proof. To do that, the normal operation, a normal algorithm, what these miners are following, they try to create a hash which have a linkage from a previous thing. They do record a time stamp when the transaction is happening. At the same time, they add a nonce, they add a random value to make it more complex. The first part of the hash function will tell you about what the previous transaction, what was the previous block. The second part will let you know about when it is happening. And the third part, to make it more complex, that nobody can solve it easily, they are adding a random value. It's a general practice in a Bitcoin. They will add either 18 or 20 zero as a suffix. The purpose of nonce is not designed by any mathematical concept. It's just to design or just to add more complexity into a header. Because if my header is complex, it becomes impossible to solve this hash function by any outsider. To make it very simple in your real life example, if I'm writing my PIN number of a bank, let's assume I enter into an internet banking, I try to write a PIN number. What exactly they are thinking? They are trying to create a PIN number which becomes impossible to memorize by anyone else. But it's not impossible for me because I know the sequence. If I'm creating my PIN number, I know that I write down 4 numerical in advance, then I use a special character, then I use the alphabet. So I know my PIN style. As a miner, I know how I am creating. So it becomes easy for me to solve. But at the same time, if someone else try to enter into my block, someone else try to create a malicious activity in my bank account, we don't know how is my psychology, how I have created this random number. Am I using alpha number first or I am using a numerical number in advance? So this hash function, when a miner is creating this hash function for their block, the first thing they have to create a linkage with the previous block. Like if I am a miner, where and I receive a 12.5 Bitcoin now. What I do is when I'm adding my block into blockchain, I create a reference from a past block. So the first part of this hash function is creating a linkage with the past. The HK will be linked to HK minus 1. The second thing, I'll add a time stamp. It means when I have created this Bitcoin, should I create it today? Should I create it, let's say, 16th of January 2021 at a time of 9:30? So that should have a timestamp. And after that, I'm free to add my random value. So this random value becomes very complex. That random value can be only solved by the expert person or by a challenge response team who is well known about I am creating this random number. Like if I have a team or you got to know that when sir is creating a pin, he adds 4 number in advance, then special character and then alpha number. You can try to solve my hash function by using a different algorithm. Until unless that is not known to you, you can't solve it. So that's the purpose of designing this hash function, and that is the purpose of giving a header name which consists of key things. Fine. I think now it's clear to everyone. Become clear.
Yes, sir. Okay.
Okay, fine. So now I'll give you just a picture of a Bitcoin header. You can easily understand what are the information given over here. See, this is a typical Bitcoin header. Here you find that number of transactions happening into this Bitcoin is 2,580. Okay. What is the total output number of Bitcoin into this block? What is the estimated transaction volume? Here, when we are talking about the height of chain, it simply explains how many people are associated with this block. How many people are associated in this single block of a Bitcoin? It says that 5312. This is always talking about a main chain. It says that total 5,312 people have involved into this transaction. Then we have a timestamp when it is created, when the miner have received a Bitcoin, what is the timestamp over here, what is the received time, and it shows that the miner name is BTC top. The last one, the blue color is talking about a miner name. The miner name is BTC top. So BTC top is a miner who have created this block and added into a blockchain. Here we find a nonce over here. He has created a nonce which is 900, 685, 155. It's just a random number. There is no you can say mathematical calculation for it. It's just a random number he used to add a more complexity into this header. So after seeing this all detail, or when you are creating your own blockchain, You should be remember that header and block is the most important parameter which will add security into your block. Fine. So next slide will enter how to transact into a block. Like you have created a block, you added this block into a blockchain. So how any can make a transaction into it? Because making a transaction, it means I have to add a value into this block. Because I already told you that block have a two parts. One is a header, other is a transaction history. So transaction history or a transaction is always talking about that when I'm making a transaction, it will work on a concept of a Markov tree concept, or it work on an algorithm which is called Markov tree algorithm. It means the transaction should be validated every time. Transaction should be validated every time. It simply says that my transaction, when I'm try to transact into any block, I have to create a temper proof, or I have to create a hash function that can be only solved by a given number of person or a limited number of persons. So at the time of transaction in any block, when I'm putting a request to buy or when I'm putting a request to sell, every request will be converted into a mathematical hash function. Like in our previous example, when Alice tried to transfer a 50 BTC to Bob, when they are sending this message, automatically that transfer message will be converted into a complex mathematical hash function. Now it's a responsibility of miner to solve that function, or it is a responsibility of challenge a response team who can solve this entire function and validate your transaction. Yeah, this is the right transaction since Alice already have this much Bitcoin, so they can easily transfer to the bot. So transaction in a blockchain is not that much tough like a designing a header file. Here only what we have to create, we have to create a reference of all the transactions which is linked to the pertaining party, which is linked to the particular node, which is linked to a particular person who try to buy or sell Bitcoin. So here what happens, if I'm making a request, my request will be automatically converted into a hash function. This is a hash function which is created on my transaction. Once this hash function will be solved, validated by a miner or any other challenge response team as a PWS, as a proof of work. The technical term what we use over here will be either is a challenge response team who will solve this puzzle, or it will be recorded as a proof of work, POW, and that POW will be recorded and transaction will be complete. Every time either I'm buying or sell, the transaction will be recorded from a seller to buyer. So first, it will create a hash function for selling activities that will be solved, validated by a miner, or it can be solved and validated by using a concept of some concept, like most of the nodes is ready to accept or ready to validate. Once it's validated, it will added into a transaction in your transaction part of your block, and it will keep on growing. Like if today 10 transaction happen, your block will be increased by 10 more, added by 10 more transactions. If tomorrow 100 transaction is happening, your block will add 100 more transaction into it. So this transaction view is something that will keep on increasing every day. So here, as a developer, I does not require to add more value. As a developer, I cannot keep a control on it. When we are using term cannot keep a control, it means I cannot stop anyone to enter into my block since it's a permissionless block. It's a permissionless blockchain. So I do not want to stop anyone to enter into it, but definitely I want to stop any malicious transaction into my block. And to do that, I rely on a hash function. I rely on a hash algorithm only. Fine. So that's the transaction part. So if you come on a summary of any block, the block always have a two parts, the header part and a transaction part. The purpose of this block is to create a security into entire blockchain. Without designing a foolproof block, you cannot say that my blockchain is 100% secure. So block is something which is dynamic in nature. The block is something which will keep on changing every time. If any transaction is happening, definitely the block will change. That block will record a new transaction. Even when transaction is happening, there will be a big change into your header because the number of transactions will increase. Although the address of a block, the address of a header will remain fixed once it's created. It's not going to change either in the HK-1, or it's not going to change the stamp, or it's not going to change the nonce value, but the number of transactions and height of your block header will keep on changing. So that's a summary about a block. When we are creating a block, we will create a key part of it. We will write an algorithm for a header. We will write an algorithm for a transaction. Although the transaction does not write an algorithm at a start, because transaction is something which is ongoing process. So just I have to write a algorithm for designing a hash function, designing or solving a hash algorithm. So every transaction will first get a hash address. Once that address is validated, the transaction will be recorded. So that's a summary about a block. Fine. Now, if I have created a block, or if I have created a block in a blockchain, and every node of my block should have a record of my block, or should keep a record of my activity. Like if a block number 5222 is there, this block should be updated to every party. Either I'm a part of that block or not, but if I'm a part of that blockchain, my block updation will take place at every place. My block updation will take place at every node of my chain. If I have created a blockchain where I and you is a part of it, let's assume Abhitam has created a blockchain for a examination purpose or to validate a marks of a student. So either you are a part of MBA class or not. But if I'm updating anything in MBA class, it should be updated at a public level to a BTech student at the same time. So the BTech student will get a updated information about the MBA student. So that is a problem in a blockchain. Like once you design a block, you have written an architecture, you have written a program for either Hyperledger, Epson, any software you are using, you have written a program for an entire block. But how I replicate it? How this information will be transferred to each and every node, which is a part of my block, which is a part of my blockchain. Because if I'm updating a marks of MBA, MBA is a part of that block, so everyone will get the information that MBA block have a 220 students. I have changed a mark of student, let's say student X, roll number 1. It will automatically update it to all the roll number till 2022 because they are a part of this block. So they are well connected. So they get the information that marks of roll number 1 has been changed from 20 to 25. But how this information will transfer to my BBA student? How this information will be transferred to my BTech student? How this information will transfer to my vice chancellor? Because since everyone is a part of this blockchain, and as per concept of blockchain, every node have a right to create their public ledger, everyone have a right to create their local repository. So that concept used as a replication. That concept is used to create a distributed sensor. So step one, you will create a block. You will try to secure your block. One block security is achieved. I try to create a replica of it. When we are using term replica of it, it simply says that I have to write an algorithm where everything will be replicated at each and every node. If block 1 is getting a certain updation, it should be updated as another block, either it's a part of it or not. If I'm making a change into node number A, simultaneously there should be updation to a detail or a local detail what is kept with a node number 3. That concept is required replication. And why I require replication? Replication simply ensures there will be no failure into a system. Because if I'm not replicating my information, let's assume all the information is kept with one block only. Block number A is keeping the information, or MBA student is just keeping the information about changing their mark. And I'm keeping that information in my PC, which is acting as a local server. If something went wrong with my PC, if something went wrong with my storage, so it will simple a failure case, just like a centralized network. If something went wrong to the server, nobody have a right to extract it. To overcome that issue, the distributed network is talking about a concept of sensors, the concept of replication, that the status at a one node will automatically replicate, automatically update at each and every node. So the second step of designing a blockchain, first I secure my block, then I try to replicate it. And when we are using a replication, it simply says that every information should be updated to the last block, to the last mined block. Like if I'm buying Bitcoin from a block 5213, it will update it in a block 5335. It will update it in a block 0. It will update it in a block 1. And every time it will create it as a replica. When we are using term replica, it means it is created very much similar to it. It will do a cloning process. Replica is simply a cloning process. What is here, that should be very similar to it without any deviation into a second part, or you can say it's a creation of a mirror image. So any update in a block will be updated everywhere, and that concept is called consensus. That concept is simply used as a philosophy of consensus, which explains that your current status, your current file, your current transaction will be updated at everywhere. And this consensus algorithm guarantee you a zero failure in a blockchain system. This is a consensus algorithm. This is a replication process which makes this decentralized network a failure free. Like I updated a marks of MBA, something went wrong to my PC, but I'm not worried at all, because that record is also kept with a BTech student. So if my system is crashed, I'm not bothered at all. When I re-link into this chain, automatically my ledger will be updated and I'll get all lost record as a replication. So that is happening. The chances of failure become zero and become very minimal until unless you not lost your network. Because you are a part of this block and the block is connected to our internet or any network. Until unless I'm not eliminated from that network, the chances of failure is zero. And that is only happening due to the designing of a block, which is very secure. And then I'm writing a census algorithm, and that census algorithm will help me to make a failure proof system for me, which make a failure proof transaction environment. That's why from 2008 till 2021, there is no evidence of malicious transaction in a Bitcoin network. Although there was a rumor in 2018 and 19 that due to a loss of a main miner who have kept all the record of Bitcoin in their PC and that is not replicated, it may create a problem on a Bitcoin network, but actually it's not happened because even at death of a main miner or a person who have started the first mining concept, the Bitcoin system is still intact. The logic behind is a consensus algorithm because the person had used the consensus algorithm. Now, we do have a certain question regarding this. Like, if I'm designing a consensus algorithm, but if I try to replicate my block at every node, what is the security? What are the, you can say, chances that nobody try to temper it? Because once I give a permission that my MBA marks will be updated to BTech student as well. Like I'm changing a mark of roll number 1 in MBA. It is known to the MBA student. Same time, the CS people or a BTech student have access of it. So although it is try to create a failure-free environment, but it also creates a problem of tampering into it. Because it may be possible the BTech student try to temper the mark, and when it transfers to someone else, like medical student, they'll get a tempered information over there. That can be a general case in a network setting, or that can be a general case when I'm creating a replica of a block. So to overcome that situation, this census algorithm have a certain pre-approved designing. Like when we are talking about a pre-approved designing, the first design is a rule of longest chain. The rule of longest chain is the first preference which tries to stop us for creating or to stop us to create or to temper a block of replication. The first and simplest concept is known as a rule of longest chain, or always the longest chain is accepted while validating any transaction. The rule of longest chain is a very easy to understand. You see, there is this is a diagram where all different blocks are linked to each other. Here, if you find that block number 1 have linked to block number 3 as well as block number 2, while this block number 3 is just linked to block number 6, while block number 2 is linked to block number 5 or block number 4. Similarly, when blocks increase henceforth, they will create a more tree-like structure, more you can say the more complex structure, web-like structure to us. So it's decided, or in a consensus algorithm, it is accepted that every time we try to follow the longest chain for an authentication purpose, this longest chain may be a multiple chain within the same network. Like if you see here, block number 1 is going to block number 2, then block number 5 to 1, 2, 3, 4, 5, 6. Again, if you come here, block number 1, 2, 3, 4, block number 9, it's 5 and 6. So again, either this is the longest or this can be a longest. Similarly, I can go from block 1, block 2, block 5, block 7, block 9, and rather than going to block 11, I can come on a block number 10. Again, it becomes longest. Right. So, it's a simple concept. It says that in a consensus algorithm, always give a preference to a longest chain, because when I'm using a longest chain, it becomes a tough or tampering of data become a near to impossible. But when I'm following a smallest chain, or when I try to rely on a single block, it may create a problem of malicious transaction, or it may create a problem of tampering of my block. So, see a situation, as you know, that hash function of a block designing, it always talk about a three parts. The first one, relation with a previous, that is hk is related with hk minus 1. Then it's talking about the time stamp. Then it's talking about the nonce. Fine. So at a time t1 or t0, the first block will be added into a blockchain, that is block number 1. At time 2, that is t1, we have created two blocks, block 3 and block 2. At time t2, that is a third timestamp, I have created three blocks, block 5, block 6, and block 4. Again, at the next time t4, I have just created one block. Then I have created again a two block, 8, 9, and again created a block. So the time stamp of these two blocks will be same. Block 1, t10, here t1, the time stamp of both blocks will be same. Either you are talking about block T2 or you are talking about the block 2 or block 3. The time stamp value will remain same because both are created at the same time. So if you go back into writing a hash function for a block header, I already explained the hash function is written as hk equal to the hash of previous block, that is hk minus 1. Then we have to write a timestamp, and then we are writing a nonce. So here, when I'm writing a timestamp for 3 and 2, the timestamp will be same. The timestamp for 3 and 2 will be same. So automatically my blockchain will reject a one timestamp because the hash function for two blocks cannot be same. The hash address of a two block in the same chain cannot be same. Because here the block 3 is related to block 1, so the value of hk minus 1 becomes h1. Similarly, the value of hk minus 1 for block 2 is remain block 1. While the timestamp will remain same. If I choose a normal nonce, that's a random number 20 times 0. So the hash address for block 3 and 2 will remain same, which is next to impossible, or you can say which is totally impossible to add into a chain. So automatically the block will keep a check on the entire blockchain algorithm, or maybe you can say the consensus algorithm, will keep on check on creation of a duplicate hash function. As and when it finds a duplicate hash function, automatically the hash function, which is not creating a longest transaction, which is not creating a longest chain into particular block, will be eliminated from your system. So your system will remain intact, your system will remain tamper proof. Fine. So if you see a simple structure, when you are creating a new block, it may be possible. When I have created a new block, which is indicated in a green color over here, automatically it will add into a longest chain. It will not going to add over here, or it's not going to add over here. It will follow the consensus algorithm and it will automatically go and add. Yeah, the question is, it means block 3 will be removed. I'm coming on that. Just hold a moment. That is called orphan block, and how it will remove, we are coming there. So first, here is just try to understand which block will be accepted. What will happen to orphan block? We are coming there. Don't worry. So as per consensus algorithm, it's very much simpler, very much simple and very well explained to us that since a block number 2 and 3 will have the same hash function, automatically we have to accept one in a chain. I cannot accept two roll number in my class. Two person with the same roll number, they will not accepted in my class. The two students cannot have a same registration number. The registration number should be different. It should be differentiated by something. Like if I'm talking about 2019, 2000, roll number one. I cannot accept two students with the same registration number in a college in my blockchain. Similar to that, the two blocks with the same hash address cannot be part of my chain. It will create a problem for everyone. So that's an algorithm, that's a permissionless consensus algorithm which says that always accept a longest chain which is available into your entire system. But here, as you see, we have a three longest chain. Block 1, 2, 5, 7, 8, 12. Then block 1, 2, 5, 7, 9, 11. Block 1, 2, 5, 7, 9, and 10. So which one is the most suitable? Which one is the most appropriate? How I can find out this is the most appropriate for me and this is the something that I accept. Right. If you see the next diagram, it says that if a new block, a new mining block has been added, this is automatically added into a longest chain. 1, 2, 3, 4, 5, 6, 7, 8. So this is added into it. It's not adding the chain or the chain which is left in number. So what will happen to the remaining block? Will it become a part of it? So here we have to write a fork algorithm. We are finding that my block is creating a fork. My block is divided into a different long chain. In that scenario, we have to think about a new algorithm, or we have to add one more parameter, which is called a concept of orphan block. The block which is get rid of my blockchain. Although when we try to get rid of my block, it does not mean that I'm eliminating the transaction which is made into that block. That block is simply merged with a block 2 after validation of that transaction. Because I cannot create two blocks with the same timestamp at the same time. So it may be possible. Why it's happening? It can be happen in a situation when I'm trying to post my transaction, my PC may lost a network for some time, may got a certain problem. So my transaction is get delayed by nanoseconds. Like I'm making a request to buy a Bitcoin from a same block. At the same time, you are also making a request to buy a Bitcoin from a same block, but due to differential in a nanosecond, the transaction hash code has been changed. So if that is happening in your consensus algorithm or architecture of the blockchain designing, these blocks will be considered as an orphan block, and it's a duty of a miner to find out the similarity between these blocks and create a sequence of it. Like rather than going from block 1 to block 2 and then block 2, we try to create something. If block 1, let's assume block 3 is have a timestamp value 912.03, while block 2 have a same timestamp. So while solving a hash function, they have to find a difference even in a nanosecond of that block. And fortunately, if they find any difference even in a nanosecond in a time, that orphan block will be added back to a chain. If they are not finding any difference in a timestamp, it's a method of elimination of malicious transactions. If there is no even a nanosecond difference between block 2 and block 3, it simply says that block 3 is a malicious transaction. It's a transaction which is not validated by miner, so automatically it will eliminated in later stage. Fine. So by using this a simple concept of a long chain acceptance, by just using a simple algorithm of acceptance of a long chain in a census algorithm, I can create my entire environment as a tempered proof. I can create my entire environment which is free from all type of this malicious activity, which is free from all type of this fault or default type of transaction. Understood? Now, it's not necessary that every blockchain will use a concept of a longest chain or every blockchain will use a concept of a orphan block. It's a Bitcoin which have used this algorithm. You are free to use a different algorithm which is available in the market or which is available to a network universe, like as a challenge response scheme, as a challenge response algorithm. You can accept a proof of work, you can accept proof of service, you can even design your own algorithm which you find is a more suitable to make your blockchain tamper proof. It's not like that you are bound to use this concept of a longest chain or you are bound to use a concept of an orphan block. So every cryptocurrency, every transaction which is happening into a market, they are designing their own algorithm. If you see a detail of a different coin that is exist into a market, you can find that their features are different to each other. They are using a different concept of blockchain. Someone is using a decentralized, that's a Bitcoin most accepted, while Bitcoin is using a hashing algorithm, which are a different concept, while someone is using a citizen science concept, someone is using a different concept over here. Like if you see the Bitcoin, they work on a citizen scientific approach, while if you see that Ripple, it has a used for a peer-to-peer debt transfer concept. It's not necessary that we are bound to follow these algorithms, which is used by a Bitcoin. But since Bitcoin has used and it's most accepted, we are talking on it. You are free to design your own algorithm. You can even use a different algorithm used by a different coin, different currency, different blockchain to secure their system. But ultimate security depends on a key thing. The, you can say the summary of all these outputs, the summary of what we have discussed till now is if I want to secure my blockchain, I want to create an aspect of tamper-proof and failure-proof network system, I will rely on a blockchain design and the block designing the first aspect. I design a block in such a manner that nobody can temper my block. Every time my block should be get a validation, and to validate it, I will write a complex hash function. That's the first thing. Second thing, when I'm designing my block, the transaction should be recorded in a form of hash address. So there will be no identity of any person in my network. Every person will be known by their hash address. They will not known by their name. Like I do not want to know Mr. F. I just want to validate it by a hash function. The third thing, every node should have a same information in a replicated manner. Every replica, every node in my block should get the same information. The information which is stored at every block should be consistent enough that there should not be deviation in sharing of information. And that can be only created by a concept of a challenge response algorithm that can be created by a concept of consensus algorithm. If I'm able to implement all these algorithms in my network, my blockchain become a temper proof. My network becomes a temper proof from any malicious type of transaction. Nobody can create a malicious transaction in my network. Why? Although these algorithms, what we have discussed, is mainly pertaining to a Bitcoin. After that, there's so many evolvement happen into a blockchain and different currency, different transactions, different supply chain use cases, healthcare use cases are using a different algorithm to safeguard their blockchain from this malicious transaction. But still, the concept behind it will remain same. We have to design a block, and block the designing of block structure has not changed at. Either you are talking about a Bitcoin, you are talking about an Ethereum, you are talking about a Ripple, you are talking about any type of transaction which is happening into a market. The structure of block is remain intact. What is changing is the changing the acceptance of consensus algorithm. The designing of block will remain intact, but the consensus algorithm is changing. When I'm creating a replica, when I try to transfer information at every node, that algorithm is changing, which is changed from a requirement of a company, the change from a requirement of the designer and miner. Fine. So what we have talked about till now, it was just a detail about a permissionless network. In permissionless network, we have discussed about what is distributed ledger. Then we discussed about a cryptography, which may be like a TemperProof. Then we discussed about a block architecture, a replication of it. We have discussed about a consensus file. We also discussed about the economy of a blockchain. I'll show you a table, how this miner is getting a benefit of mining of it. So what we have discussed till now. From next class or from henceforth, we will discuss about a blockchain too, because when you are doing this, when you are designing your blockchain by own, you are not going to design a permissionless network. What you will design an enterprise version of a blockchain. Either you are using a Ether platform that is given your lecture note, but I prefer Hyperledger. So anything you are designing, you try to design an enterprise version of a blockchain. So after discussing all about the permissionless, the next step will enter into a discussion about the enterprise version of a blockchain, right? Which is mainly move around the idea of a smart contract. The concept behind designing a permission blockchain is a smart contract. So if you have any problem, please let me know. Although I'm not getting your voice, so let me disconnect my Bluetooth so I can get a little bit voice of yours. So we can go ahead on a discussion. If you have any problem, please let me know. Have any problem, please let me know. Today I'm going to share. Can you hear me?
Yes, sir. Now it's clear.
Okay. I'm going to share a new document which tell you about a use of blockchain in a health. Clear this one on WhatsApp. Try to read it, how the blockchain algorithm can be designed for a healthcare. So that will help us for a next class. For next class, we are entering into a blockchain 2 version, which will use for an enterprise version of a blockchain. Fine. So enterprise version, mainly we are talking about the smart contract, and there will be a permission to enter into this blockchain. So if you have any doubt till now, please let me know. Else we'll end our class over here. Pardon? So we'll end our class over here and we'll meet tomorrow. Meanwhile, you try to read a document what is shared yesterday and what is the document I'm going to share now.
Yes, sir. Okay.
Fine. Take care of